The first mechanism based on to the process of halogenations of benzene. So our reagent should be halogen, either bromine molecule or chlorine molecule, the presence of a Lewis acid, so that by using the bromines in our chemical equation, one atom of the hydrogen in arene can be substituted with one bromine atom that it can be processed electrophilic aromatic substitution reaction, and it must be involved three-step mechanism. So the first step 1 should be electrophile must be formed because our type of reaction is electrophilic aromatic substitution reaction. So every time in our first step, your electrophile species must be formed. While in step 1 in halogenation, we need to form the complex structure first. Next step, the formations of uranium ion, and final step, the formation of final product by using the process of loss of proton. In step 1, our target is a complex structure should be formed, which is our electrophile species. So it must be involved between bromine molecule. So this bromine molecule for each atom consists a 3 lone pair in form our Lewis structure must be reacted with our Lewis acid, which is FeBr3. So what happened in the process? Bromine atom is more electron negativity, which is more electron density at here. So the one of the lone pair here will attack toward to the fluorine Fe, ferrum, that consists the empty p orbital, and it can form chemically bonding together. So finalize, our intermediate product can be formed as a complex structure. So means for the second bromine atom, it can form covalently bond with the FeBr3 molecule, and next we check the lone pair presence inside the molecule. So we need to trace the formal charge for each atom. So the first atom bromine, 7 valence electron minus electron around itself. So 7 minus 7, the formal charge bromine atom is 0. Second atom bromine, the valence electron is 7 minus 1, 2, 3, 4, 5, 6. So formal charge become positive 1 charge, and therefore Fe atom will accept another 1 electron, and the formal charge here become negatively charged. So therefore this is we are labeled as a complex structure. Okay, for the second step, we focus to the terms of rhenium ion. So rhenium ion so means this step must be involved between complex structure and aromatic ring. So we draw it again, the complex structure from the step number 1. And this molecule must be reacted with the arene structure. So plus aromatic ring that consists of 3 double. So this bromine already have positive charge and negative charge. So next we must be traced. Okay, the bond cleavage must be occur at where? So from the 2 atom bromine inside the molecule here, so totally the bond cleavage must be occur between first bromine and second bromine. So, according to the rhenium ion, we have the multiple bond at here. So, what happened? One of the bonding pair here will attack the one of the first bromine atom in the complex structure, when the covalently bond formed between them, and simultaneously the bonding between two bromine atom will break, which the two electron will give directly toward to the bromine atom, because this bromine inside this molecule less of electron, and the product can be formed as a rhenium structure. So the product form, what happened to the rhenium? Okay, So from this benzene, we have a double bond, so it will become two double bond only. So mean one atom bromine will added to the carbon atom, and the neighboring carbon atom must be positively charged, which is carbocation. So I draw the plus symbol inside the structure. Okay. So, and what happened to the rest compound here? So it will form Br. First, we have a two lone pair remaining bonding with FeBr3, and this is we have a lone pair here. So when we check the formal charge for this bromine, negative. So means overall charge ion is negative because the first bromine atom is negative charge. So according for here, the formation of intermediate product, we must be show the resonance structure. So this is why we label as a rhenium ion. So what happened? The process involved, the resonance must be based on to the alternation of the electron. So the closer position of the double bond toward to the positive charge must be moved first. So the first double bond will move at this place first. So it can be formed the new structure of rhenium. Okay, the new bonding, remaining first bonding and remaining our bromine atom. Okay, and the new positive charge occur at this place. And another part, the remaining second bonding pair change position at this area, and it can be formed your third structure possibility. This is become double, and this is remaining double and the positive charge at this place. So Br atom at this area are remain. So when we repeat again, it will form reverse process and your arrow must be full headed both sides. So this is the ion form, so you must be bracket them together, and we call this is the resonance structure of rhenium ion. Next is the step 3. So in step 3, by using your first structure in resonance of rhenium, we rewrite again in a step 3. In step 3, we need to prepare our final product, which is our product is a hydrogen substitute by one of the bromine atom. So we need to copy the first structure in rhenium, must be reacted again with the complex of FeBr4 minus. So this reacted with this molecule. So what happened? So this is a process of replacement. So we know that the similar carbon attached bromine, it already have one hydrogen atom. So the process is substitution. So the mechanism involved one of a lone pair here will form bonding with the hydrogen atom, and this bonding pair will stabilize their own carbon and the carbon carbocation together, and it will form a new the multiple bond, and this form occurs simultaneously. So mean the bonding with Br and fluorine will break, and finalized product you can produce your target product bromobenzene form. So the place for here, double bond, we have a 2, and we add another one, and we have already bromine is added to here, and the side product is molecule HBr, and the rest FeBr3 form again.